Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to continue our discussion on the measures of central tendency, talking about mean, median, and mode. And so we left off in the last video by describing broadly what a measure of central tendency was and a measure of dispersion was. And we said that we were going to talk about mean, median, and mode. So what I want to do in this video is I want to go through what each one means and then how we calculate them on a sample data set. So let's go ahead and give ourselves a little bit of room here. And let's start first by talking about median. Let's talk about mean first. So mean or average is the average value of the data set. And I think for mean specifically, it makes a lot more sense to look at the equation for it. So let's go ahead and look at the equation. So I'll use blue here. So mean, and because it's used a lot, you'll often see mathematically denoted as x bar equals this giant sideways e thing. This is called the summation of x sub I over n. So this sort of horrific looking equation here, this is simply saying that to get the mean of x, you add all the values for a variable, and then you divide it by the number of records or observations. And this is going to give you the average value of the data set. So let's go ahead and look at an example of how we can calculate the mean by looking at some data here. So these are the same data set. This one is just ordered by height, so we can ignore this one for now. We're going to focus on this top one right here. And you can imagine that this would be just 11 students in a classroom that we measured their height, which is the height column here, and we recorded the color of their shirt. And so just to recap a previous skill here, height would be in this case a ratio, a form of ratio data, and shirt color would be a form of nominal data, right? Because nominal data has no implied ranking, and we can't say that one color of shirt is better than another. So we have two pieces of data here. So let's go ahead and calculate the mean of our height. So let's switch to weight here. So we're going to have mean of height. So as we said before, it's the sum of all of the observations divided by n, which is the number of observations. So what does that look like here? Well, the number of observations we have 11 students, so our n is going to be 11. The sum of the observations, so this top is going to be 6.5 plus 4.5 plus 6.8, on and on and on and on until 6. Right, so it's these 11 numbers right here added together divided by 11. So if you aren't familiar with mean, hopefully this is a very basic review for everyone, but if you're not familiar with mean, I would encourage you to pause the video right now, do the math, and confirm that you get what I got. So if we sum these 11 values here, our top number is going to be 60.9. And our bottom number is still 11. So if we take 60.9 and we divide that by 11, we end up with a final height of 5.54. Okay, so that's mean, the total of the observations divided by the number of observations in the data set. So that would be the sum, in this case, of height divided by the total number that we collected. So that's mean. So mean is probably the most widely used measure of central tendency. The other part of this, though, and this is the key part, is it's not used for nominal or ordinal data. Right? For example, those shirts, it wouldn't make sense to take the mean value of the shirt. Okay. So let's go ahead and talk about mode next. And we'll do median last because median requires a couple more steps. So mode is just the number, the value that appears most often in the data set. Right, it's the number that appears most often in the data set. So there's no special equation here. We just count the number of times each value appears, and the one that appears the most is our mode. So let's go ahead and look at our sample data again. So in this case, we're going to do both the mode for height and also the mode for shirt color because we can do mode for nominal and ordinal data. So let's see, what is our shirt color mode? So mode for shirt color. Let's see, 1, 2, 3, 4, 5. So red has 5 observations. Green has 1, 2, 3 observations. And then because we have 11, we know that blue also has 3 observations because we know they have to sum to 11. So 5 and 3 is 8, 8 and 3 is 11. So we would know then by sort of default here that because red has the most observations, that red is the mode for that variable. What about the mode for height? Well, we can look through and we see that 4.5 has 2 and 6 has 2. So this actually has 2 modes because it shares 2 values. So it's 4.5 and 6. So again, to recap, mode is just the number that appears most often, and it's mostly used for nominal and ordinal data because it's the only one we have, basically. So mode is used mostly for nominal and ordinal data. For nominal and ordinal data. And again, it's just the number that appears most often. So finally, let's talk about median. Make that a little more centralized here. So median is the value above which 50% of the data exists. And below which 50% of the data exists. So put another way, this is the middle value. Of the data set. Okay, so calculating this is pretty straightforward, but it does require a bit of an explanation. So there are multiple steps. The first thing we have to do is we have to order our data set. Then we have to find the middle observation. Right, we have to find the middle observation, and then the value of that middle observation is the median. The value of that middle observation is the median. So let's go ahead and just take a quick look at how this works. So if we scroll down here, so the first thing that we have to do, let me scroll just a little bit so we can hopefully see the instructions. Okay, so up here is what we have to do. The first thing we need to do is order the data set. So that's actually what we've done here in this second data set. So I'm going to make a note that this data set here is ordered. Right, so you'll notice that this data set, the heights were just sort of randomly distributed based on the person, whereas in this data set, we've ordered height from smallest to largest. So that's what we mean when we say order the data set. Next, we have to find the middle observation. So there's a nice little equation to do this. The middle observation is going to be n plus 1 over 2. Right, this will always give us the middle observation, where n is the number of observations. Right, this n, this is the number of observations. Okay, so n plus 1 over 2, in this case, that's going to be 11 plus 1 over 2, which is going to equal 12 over 2, which is going to equal 6. Right, so in this case, our sixth observation is going to be our middle observation. So if we go to our ordered data set and we go 1, 2, 3, 4, 5, 6, I'm going to change colors here. We know that this right here, this is going to be our middle observation. And so what we do then, so we found the middle observation. The value of the middle observation is our median. So our value here, this 5.6, this is going to be our median. So the value equals 5.6, which is our median. So this means that 50% of the observations are below 5.6 and 50% of the observations are above 5.6. Okay. So let's go ahead and wrap up this discussion by saying, why would we want to use median over mean, right? Why would we want, we have mean, mean's really straightforward, it's easy to understand. Why would we want to use median instead? So median works best when we have large outliers. Right? When we have large outliers. And in case you aren't familiar with an outlier is basically just a value that is very, very different from the rest. So a good example of that would be if, say this 6.8, say we had someone from the basketball team instead, and he had measured in at 7.5. Right, he would be a full foot taller than the next highest observation, and so clearly he would be an anomaly in the data set. In that case, right, we would still get the same median, right, because it wouldn't change the order. Right? This 6.8 would be 7.8, so it wouldn't change the order. The median would stay the same, but you can see that the mean or the average, right, would change substantially. So that's why you want to use median. If you have significant outliers on either side, either really small or really large, you would want to maybe consider median instead. So hopefully this made sense. I know there was a lot here. This is a slightly larger video, but if you have any questions, please reach out. Thank you.